This is the fourth tutorial on the creation of the displays and PDFs for the Schmidt Sanskrit-German dictionary. We've got a good handle as described in the third tutorial, on the head words and how they're related to the digitization. And all of the displays are done from an XML file that is constructed from the digitization. So the file is schxml.xml constructed from sch.text. There's various ways that this could be constructed depending on how much markup we wanted to add to the dictionary, but in this dictionary case, very little markup is added. This DTD file is a standard in the XML world for describing the form that an XML file takes. And in our case, the XML file is constructed as a sequence of H1 records, which are composed of a head, a body, and a tail. And the head has just essentially the identifying information for the key. It's got the key 1 form, the key 2 form. That's actually not right. The key 2 form is in anglicized Sanskrit. And some of the records have a homonym number, and that's kept there too. The tail has essentially the record number for the head word, which is artificially assigned in this case, but is still uniquely identifies a particular record by a number. And the page identifier, the page on which the head word occurs, PC. And then the body element is essentially just the text of the body element has only 2 element forms in it, and it's essentially just the text of Schmidt text with the italic parts of Schmidt text. So see that there's a lot of italic material in the body of the text, and that's marked with an I element, as opposed to the curly bracket % notation which it takes in the digitization. And sometimes there's a percent, there's a curly bracket pound sign in the digitization other than in the head word section, but that's rare in this case. So essentially all that's done is to convert curly bracket % something or other % curly bracket to angle bracket I, close angle bracket something, and then a closing XML /I in angle bracket. So we could look at a bit of the XML file here, and you can see it's very simple. We've got this angle bracket notation to indicate curly %, and we've got tail element and head element and body element. So it's a very simple structure here. A more involved analysis of Schmidt might very well identify such things as the literary sources in some special markup, but that hasn't been done and isn't done currently in this. That would be a good thing to do. It'd make it more useful if the literary sources were marked as they are in the Monery-Williams dictionary. In the process of this, a few errors are discovered typically, and that was the case here. For example, XML requires that angle brackets match up, and it would happen to be the case that in this, in one place at least, there was a curly percent matched up with a wrong. There's a curly pound sign matched up with a percent curly, so this didn't match. So a change had to be made, changing this pound sign to a percent so that it would match properly. And there were a couple of other cases like that. Not very many. So now we know the form we're aiming for in the XML file, and then a program creates that file using those principles. And then this XML lint program, which is a general Unix utility, by the fact that it has no output when we ask it to validate the XML file, validate means to use the DTD that is present in the doc type statement in the XML file, sch.dtd, to validate, and it validates it. So that's useful. We now know that the file has a certain form. That's why XML is useful. So now we have the XML file, which is nice. It's got a record with a nice structure, easily manipulated structure for each head word, and we can use that to make various displays of the dictionary. And there's sort of an informal framework for constructing these various displays. And for Schmidt, I have several things that to some degree automate the process of constructing the displays for a new dictionary. It could be more fully automated, but usually there's idiosyncrasies for each dictionary that make complete automation not impossible, but it would be very complicated. So I don't do that. The displays use the SQLite database, which is a good portable database that can be queried using SQL, the structured query language for its retrieval. And a simple program creates the SQLite database essentially from the XML file. And if we look at this, which defines the XML file, we see that it's a very simple structure. It's got a key that we can query on. It's got an L number, which is our L over here. And then it's got data, which is the whole XML record for every head word. And we also create an index on the key to facilitate the query lookups, to make the query lookups faster. So now we've got a database that can be accessed. And the rest of the process is really very straightforward. We have to change titles of things, change a few um, a few names of things, but it's all very straightforward. And that when we're done with that, then we have the basic display, the list display, and the advanced search display, and the variant of the basic display, which is if anybody wanted to use a mobile device for displaying, would be more compatible. So that's the WebTC is the basic display, Mobile 1 is the mobile friendly display, WebTC 1 is the list display. The list display is useful, especially in something like Schmidt, because if you look up, say, Rama actually doesn't appear in the dictionary. Schmidt is just a supplement to the Bertling dictionaries. And so who knows exactly what the words are. So here, this gives you an idea of what the words are, this listing over here, and that's quite useful. Also, there's a facility for supplying random corrections that a user might discover. This says edit this form because it's me. Normally that wouldn't appear. So users can enter corrections and submit them to me, and I don't yet have developed a good system for processing those, but as the need arises, that system will be developed. So I think that's